Okay, I guess now we're live. Welcome to CS50 Super Section. We're less comfortable. My name is Lucas Freitas. I'm one of CS50 head TFs. And this is Lauren.
Hi, I'm Lauren. I'm also a head TF for CS50.
Yeah, so today we're just going to give an overview of what you guys have learned in week 1, hopefully to give you guys a good sense of what you should know for problem set 1. So just a couple announcements. First of all, office hours. Office hours are happening from Monday to Thursday in different houses in Annenberg each day. They are a very good resource for you guys to come and ask questions and talk to TFs and even like exchange ideas with other students. So be sure to use that resource for in your favor. The second thing is the CS50 appliance. For the last piece set in Scratch, you guys didn't have to actually have an appliance. You just did everything in your personal computer. But for this problem set, you actually have to have a virtual machine. So be sure to download the CS50 appliance and set it up. And the third thing is be sure to start the problem set ASAP, just because it's much easier to find help when you're in the beginning of the week, because people tend to wait until last second to start the problem set, and then you go to office hours and there's a lot of people. While if you go on Monday, you're going to see that you can talk to TFs pretty much for the whole night, and they're going to be more than happy to help you.
Can I just stop you for just 1 second?
Mm-hmm.
So has everyone been able to download the CS50 appliance? Have people tried?
To download, by the way, you can get the instructions at cs50.net/appliance.
Right. And it does take a little while for our sysadmins to get you a license key. So sign up for the free trial first. That way you'll have it for 30 days. And then wait for your license key, which should give it to you for a year.
Yeah. Okay. So first of all, let's talk a little bit about the CS50 appliance. So the CS50 appliance is actually a virtual machine that you're going to run in your own computer, which is basically running another computer inside your own computer, which is pretty cool. And actually, it's used everywhere. People who do tech would know that this is used all the time, so you can have multiple computers in one device. So let's actually take a look at the appliance. Is this it? Okay. So when you go to the appliance, after registering, you're gonna have to just put your name and log into Harvard so we can get you all registered. This you're going to see. So basically just a wallpaper and then home and trash and then these little icons. So these 3 icons are actually the most important things that you can have in your appliance. The first one is gedit, which is a text editor. So just like Notepad or any kind of text editor, is just something that we use to write code and then do stuff with it. So the second thing that we have here is Chrome. So if you need to use the internet in the appliance, that's what you can use. And the third thing is the terminal, which is actually very sweet. So people usually get kind of scared of the terminal because it's this very old-fashioned application in which you just basically type everything with your keyboard. There's not a lot of interaction with your mouse, but actually the terminal does very good things. So first of all, let's just go through some commands they can use in the terminal.
And feel free to stop us if you have any questions.
Yeah. So the first command that we have for the terminal is ls. So ls basically means list everything, all the files and all the directories that I have at the place that I am at. So if I do ls here, I'm going to see that I have some directories. So I have the desktop, the downloads, the logs, and the vhosts. Those are in blue because they're all directories. Then you have some other files. So you have hello and hello.c, which are just files, and they're in different colors. So this is a very important command, just because so you can see what are the files and directories that you have in the directory that you're at in the terminal. So when you see jharvard at appliance and then the little symbol there, the tilde, that just means that that's the directory that you are at the moment.
So typing ls is almost like clicking on the folder that is listed right there, and it kind of shows you all of the contents that are within that folder.
Yeah.
Is there text after the hello.c?
Oh, you can't see that. Because it's blue.
Oh yeah. It says logs and vhosts.
So those are just other folders. I'm sorry, it's really hard to see.
Yeah.
Maybe if we turn off the lights. Yeah.
Yeah.
Colton, do you want to try and find the light switch? Sorry about that. I didn't think about.
But it's basically, yeah, if we can. Yeah? I don't have that
Oh,
feature.
he doesn't have that.
Have to install it.
Okay. Well, there's just like a lot of natural light in this
Yeah.
as well.
Okay, let's just assume that there are two other directories there.
Just bear with us. This is
Yeah.
the only part that you'll be looking at the terminal.
Yeah. Okay. So the next command is basically maybe you're trying to do, maybe you want to organize your files, for example, all your C files in one directory, but you don't have a directory just for C files yet. So you can basically create a directory using the terminal as well, which is the same thing as like right-clicking and saying new folder. So the command is make directory, which is mkdir. So basically like make and directory. And then you can put the name of the directory. Let's say that I want it to be called, I don't know, let's say pset1. So doing this, I just created a directory. Let's just check that it is there. So if I do ls, now I see logs and then pset1 and then vhosts. So I have the new directory there. And then after you have a new directory, maybe you want to navigate into it. So the next command is cd, which just basically means go to a specific directory. So if I want to go to pset1, I can just do cd pset1.
So CD stands for change directory.
Yeah.
I'm able to remember that.
Yeah. And now you see that instead of just having jharvard appliance, I have jharvard appliance and then pset1, because it's showing me where I am in this computer. Now if I want to go back to the directory that was before this one, I can do cd ... which just means like go to the directory that I was before, like the parent of this directory basically. And now I see that I'm back to jharvard. The next thing that I can do is rm, which is remove a file. So if I want to, for example, let's first do ls to see what I have here. So I have hello and hello.c. Let's say that I want to remove them. I can do rm hello. And it's going to say remove regular file hello, and I say yes. And now if I do ls, I see that it's not there anymore. If I try to use rm for a directory, though, it's not going to let you do anything. It's going to say, hey, you cannot remove a directory. So we have this other command called rmdir, which is basically means remove directory. And I can, for example, remove pset1. And if I do ls, I don't have it anymore. Any questions about this? No? So you guys are going to, yeah?
Is it important that you make a space after, like, whenever you start typing something in?
If I do like cd and like the directory, I have to put a space. So yeah. What space are you talking about?
The space between CD and...
Yeah, you'll have to put the spaces because cd is the command, and then the next string that you type is basically the directory, so it's like an argument. Yeah?
When you list, so all those are different directories, right?
Yeah, they're in that directory, yeah.
What are the differences among the directories?
They're just different folders. So a directory is a folder in your computer.
Open folder.
Yeah, it's just an open folder, yeah.
Right, so over here, the ones that are in blue are actual directories that you can get into and
Yeah.
see a bunch of things that are within that, which is unfortunate because you can't actually read them
Yeah.
in blue. And the ones in white are just files that are
Yeah.
within the current directory.
Yeah. So directories are folders, the other ones are files, yeah?
What's the command to reset it or declare it?
To say it, to clear?
Too clear?
I think it's clear, yeah. So you just type clear if you want, if like your screen is too messy. Any other questions? And you will learn a bunch of other commands just naturally during the semester because they're very useful. Okay. So now, let's talk about compiling. So we talked about pseudocode and source code and object code, and there's a lot of codes, and maybe like you guys are confused about that. So let's talk a little bit about what happens when you're writing a program and like you compile it and it becomes an executable file. Like those are like all like words that you guys probably heard and maybe like you're not really sure what is going on. So let's say, for example, that I want to write a program that says hello. The first thing that comes in your mind is like you kind of try to think of like how you're going to do that in your mind, and you probably think in English or in some other language, like natural language probably. And then you think, well, if I want to, for example, write a program that says hello, I would start the program, I will print hello, and then I will quit the program. So this is pseudocode. This is just basically like you're trying to come up with like a sequence of events that you're going to do to be able to write that program. Then you have the source code. And the source code doesn't have to specifically be in C. Like we're talking about source code in C because that's the language we're learning. But source code can be in pretty much any programming language that you have. So later in the semester, you're going to learn other languages. That's also source code. So for example, here, this is my source code. And then I'm including a library. And then I start main. And then I print. And you guys, Lauren's going to talk a little bit more about like all of this. So this is the source code. And what is the object code? Well, the object code is a bunch of zeros and ones, basically. So what happens is you initially have pseudocode, which is all in English. And I mean, you understand it, probably your friends understand it, and most people like would understand the idea. But computers are really dumb, and they don't like understand English. So you have to like translate that into something. So usually translate it into some programming language. And you can think of a programming language as kind of like a language that you taught your computer how to speak and to understand. So you're basically writing something in a language that both of you and your computer understand. So that's the source code. So going from pseudocode to source code, it's up to you. It's basically you doing your program. But the problem is that the computer doesn't even understand programming language. It doesn't understand source code at all. It actually just understands zeros and ones. So we have this very magic thing called a compiler, which basically is going to get the source code that you wrote in a language that both you and your computer speak, and now you're gonna transform that in zeros and ones. So basically what the compiler does is it gets source code, so in this case C, and it's gonna transform it into zeros and ones that the computer understands and can make an executable file out of it. Does that make sense? So you can just think of the compiler as like some kind of like translator that is helping you explain the computer exactly what it's supposed to do. But how do I compile? So let's go back to the appliance. And let's say that I'm doing that program. So first I'm going to create a directory here. I'm going to call it practice. Now I'm going to navigate to this directory, so cd practice. Now I'm inside practice. Now I want to start gedit. So how do I do that? I can either click here, or I can just literally type gedit, and it's going to open for me. So now I'm going to type my program. So exactly what I wrote in the slide. I'm declaring a library. I'm doing int main, void. And now I'm doing printf, hello. Oops. OK. Now I'm going to save this. So let me put it into practice, and I'm going to call this hello.c. OK, so now it's saved. So if I want to compile it, I actually can do it in two different places. I can either do it in a terminal window, so this big one, or you can use gedit that actually has a terminal window right here, so you can like very conveniently just do your code, and then you can just type whatever here and try to compile it. So how do I compile code? The easiest way that we have is by using make, which is a function that is basically going to compile your code. You just have to say make hello, so make and the name of the program. Oops. This is awkward. Sorry, I didn't save in the right directory. OK. Come to practice, and now save it as hello.c. I'm sorry. OK, now it's saved. So let me just do ls and be sure that it's here. Okay, now it's here. So now if I do make hello, it's like it spits a lot of stuff, but then it just gives me another line for the terminal, which means that it was successful. So now if I do ls again, I actually see this file in green, which is the executable file. And then I can, if I want to run it, all that I have to do is /hello. It's going to say hello right here. So it's doing exactly what I'm asking it to. There's one more way of compiling, which is using Clang. Clang is just a compiler that we have, and it's a little bit more verbose to compile it, but it just works just as well. So if I do Clang and then -o, and then the name that I want to give it to the executable file, so let's say hello, and then the file that I want to compile, hello.c, it's always also going to compile, and you have the file here, and I can just execute it as well. So both of them work. Does that make sense? Any questions? Yeah? Sorry? Command what? No. Yeah.
It's because we set the
Yeah, we're.
resolution for this thing.
I don't know if we can zoom in, but yeah, we cannot zoom in. But okay. Any other questions? Sorry. Yeah.
Can you repeat the Clang?
The Clang. Okay, so Clang is the same thing as make, but the difference is that first I'm going to write Clang, which is the command. Then I'm going to do -o, which is just what we're going to learn later as a flag. So just think that you always have to put the -o. And then first you're going to put the name of the executable file. So basically like the file that you're going to create. So I can say, for example, hello2. And then the file that I want to compile, which is the .c file. So that's hello.c. Does that make sense?
Hello what? What is that?
Hello.c. Yeah, and if I compile it, and if I do ls, now I also have a hello2 that I just compiled. And if I try to run it, it's going to do exactly the same thing as hello, just print hello. Yeah.
How come for the make you didn't put hello.c after?
Yeah, so in make, you don't have to put a .c. So in make, you just say the name of the program. You don't have to say .c. But for Clang, you should. Yeah?
In Clang, do you also have to add the L
Yes. So you also have to link to library.
Yeah, that's something we're going to use later. That's called linking, and I think we're going to talk about it later. Okay, any other questions? Yeah?
Do you put a /Clang? Or do you?
No, the / is just to open the executable file. So Clang, you just write Clang, and then if you want to open the executable file that you just compiled, then you do / and the name. Does that make sense? Okay. Yeah?
If you were to just change the text like to hello world, something like that, do you have to recompile it in order to?
Yeah. So if I want to say, for example, hello there, whoops. If I want to say hello there, I can just save it now, and I just compile it again. So let me do make hello, and if I do hello, it's going to say hello there. Make sense? Any other questions? Yeah? Yeah, so the standard I/O is basically the library that has the implementation for printf. So so that thing like right on the top include stdio, that is including a library that basically has a bunch of different tools that you can use. So one of them is printf, that is a function that basically prints messages to the screen. Any other questions? No? Okay, so now let's let Lauren move. Oh no, I saw it was a style guide. Now let's talk about.
Let's just go to the style guide.
Yeah.
Do you want to just find it in here?
Yeah. So now we're going to talk about style.
Oh, David didn't finish.
Didn't he?
Okay, so why don't we come back to style at the very end?
Yeah, okay.
It's actually being updated as we speak.
Yeah,
So.
let's wait for David to finish that.
All right. So.
Okay. Okay.
Can we switch?
Yeah.
Actually? Okay, so I hope everyone's been enjoying Scratch. Unfortunately, it's time to move away from this. Oh, is it? Fortunately, it's time to move away from these pretty programming blocks and onto C. But luckily, all of the programming constructs that you've been working with in Scratch are directly translatable to C. And we're going to start to learn about some of them right now. So let's first talk about conditions and Boolean expressions. So this is running on reserve battery power.
How is that not working? Okay, you go there. I'm gonna get the.
Try and get power. So conditions are important because they allow us to introduce logic into our programs. So here's an example of a condition within a C program. Let's note how this condition block right here, this printf statement will not execute unless the condition within the parentheses n greater than 0 evaluates to true. Now, all of the conditions within if statements are Boolean expressions, which means that there are only two options. They can either evaluate to true or they can evaluate to false. So here, this makes sense, right? N greater than 0 means that it is a positive number, which means it will print out, you pick the positive number. So there are lots of Boolean expressions that can form the condition within an if statement. We have like the less than. This is less than or equal to. This is just a funny syntax. So if you want the printf to occur if it's greater than or equal to 0, then you would choose this. So the equal just appends right after the greater than sign. Equal, which is different from just one equal sign. Equal actually means that whatever's on the left-hand side of this is the same as what's on the right-hand side of this, whereas one equal sign is what? What is just one equal sign? Assignment.
Who said that? You get candy. Oh, no, sorry. You both get candy. Okay, I guess 3 people get candy.
All right. So this one right here is the bang operator preceding the equal sign, so that's not equal to. So if this was within my condition, the body of the condition would execute only if whatever's on the left is not the same as what's on the right. I can also have just the exclamation point. So actually we'll see in a future slide how this would be used.
Any questions?
No.
No?
All right, so we can combine these Boolean expressions to construct more intricate conditional statements. So here, if whatever's on the left-hand side of the double bars or whatever's on the right-hand side of the double bars evaluates to true, then we'll print out invalid. And then down here, if whatever's on the left-hand side of the 2 ampersands and whatever's on the right-hand side of the 2 ampersands evaluates to true, then we'll print out valid. So the double bars are called the logical OR operator, and the double ampersands are called the logical AND operator. Yes?
Are those just lowercase l's?
What? Oh,
No.
no, they're actually, so they, you know the backslash, like above your return key? Do you see that?
It's actually a bar.
So it's actually just 2 bars, yeah.
Yeah?
Can you use the equal for strings?
No. We're going to learn later about something about
There's
that.
a function that you can use, but you don't
Yeah.
have to worry about that just yet.
Yeah.
All right, so what if I give this program the number 5? What will print out?
So,
Valid?
valid?
Yeah.
Okay.
I don't know who got that.
Yeah.
It's kind of scary when
Yeah.
I'm sorry. Yes?
So the double and, that just means and, right?
Yeah. So the number 5 is both greater than 0 and less than 100.
What happens if it's at 1?
So one ampersand is actually something different, and it's a bitwise operator, which you'll learn about later, but it's something that actually works with the bits of a given number.
Just think that you don't have to worry about it for now.
I think it's probably coming up next week.
Yeah.
All right.
Any other questions? No?
All right, so we've seen that an if block can stand alone, but it can also be paired with an else block. So in this case, if n is greater than 0, we're going to print out you picked a positive number. Else, meaning if it is 0, or if it's less than 0, we're going to print out you picked a negative number. Now the interesting thing here is that these are exclusive of each other. There's never going to be a case in which this and this can both print out. So I'm sure you've worked with the if-else blocks in Scratch, so this should be pretty familiar. Yes?
Do we need a space between int n equals get int and then space? And then the if statement? Like, do we need a line in between it?
Oh, the space here?
Yeah.
I mean, like that. Like you double spaced.
I double...
No, go up. Go up.
Just the line?
Yeah, like that.
Just the blank line?
Yeah.
Oh,
That-
the blank line? No,
yeah.
no, no. That's just a stylistic thing.
Yeah.
I just chose.
It's just like sometimes you just skip some lines so that the code doesn't look like a huge block of text and more of like
I
just
think what happened was I
other
originally had
blocks.
a comment here, but I took it out so that you guys would have to think about the code rather than just read my comment.
Yeah.
But in general, spacing will not really affect the way your program runs. It's more of a stylistic thing. And when we have the style guide updated and ready to go by the end of super section, we'll talk about that more.
yeah.
Okay, so there's something wrong with this program, right? Because 0 is not really a negative number. So let's see if we can fix that. Oh, crap. All right, well, you can probably imagine what this says, right? So if n is greater than 0, we print you picked a positive number. If n is less than 0, else if n is less than 0, you picked a negative number. Else, you picked 0. Now, the interesting thing is that this could go on forever. You can have an if block, an else if block, another else if block, else if, else if, else if, else, basically as long as you want. And when constructed like this, these are all going to be exclusive of each other. Yes?
So why can't you just use another if instead of
Okay, so in this case, yes, I could use another if, and it would be absolutely fine because the conditions themselves are exclusive of each other. But if the conditions were not exclusive of each other, this would force them to never both evaluate, if that makes sense.
Okay, yeah.
But
But in that case, couldn't you nest the second if and the first if?
If, what do you mean?
If the two conditions are not mutually exclusive?
If the conditions are not mutually exclusive,
should say you can, yeah, we're
but
gonna.
you want only one of them to run.
If instead of else.
I mean, yeah, there are always going to be lots of ways that you can do this. You can definitely nest them. And you'll see in a future slide that you can have multiple ifs, just one after another. But this is a way of kind of logically organizing the flow of your program.
And there's one more thing is that you asked about like putting if and then another if. That would work perfectly, but it's bad design because basically if you check the first if and you notice that the number is greater than 0, you can just like finish the program. You don't have to check if it's less than 0, right? But if you do if, it's going to check both. While if I do if, else if, it's going to check if it's greater than 0. If it is, it's not going to even look at the other lines of the code. So you're basically doing like checking it like twice unnecessarily. So that's why we do if, else if. Any other questions? No?
Yeah.
So the functionality of else if is the same as if it was just if.
No. So you're actually going to see in my next slide how an example in which it can be different. In this case, it's almost the same.
Yeah.
But all right. So here we have an example of multiple if statements, and the functionality is not the same as if I had just said if, else if, else if, else. So let's just think about what would print out if I entered the number 95 into this program. And then, yeah. So in this case, these conditions are not mutually exclusive of each other. And because there's nothing stopping this condition from evaluating, if this one already has, they're just all going to print out.
Yeah.
So how could I fix this? You can use else ifs. I could change the order of these, right? If I did this one first. Oh, well, not actually. No, that wouldn't work for 95.
No, you just did that.
But yeah, the else ifs would have fixed this.
Yeah.
Does that kind of clear up the confusion between ifs and else ifs? Okay.
So just one more time. So
Yes.
if you did use else if, it would stop.
Right. So only this first one. If I entered the number 95, only this would have printed out, and it never would have progressed to the else.
Yeah. Just kind of think of it as like, if this happens, do this. If not, that the else is like, if not, check for this, and then do that. But so like they're all mutually exclusive. You cannot get into two of those. Yeah.
Can you use a logical and for that situation? Yeah. So this is actually that's another way that we could have fixed this problem.
Yeah.
We could have defined ranges, right?
Yeah.
So I could have said if n is greater than 90 and less than 100. Well, I guess this one doesn't really matter, but here I could have said if n is greater than 80 and less than 90, greater than
Yeah.
70, less than 80. That would have also worked.
It's
You're
all.
okay
It's yeah. It's she's scared.
Don't be afraid.
It's just it's not that it will be wrong. It's just that it's unnecessarily verbose. It's yeah. Like in computer science, you always want to be as simple as possible, as long as you have the functionality. Okay. And do you want the?
You're scaring everyone. Lucas.
Sorry.
All right. So David also mentioned these switch statements in class. And so basically what's going on is a switch statement takes a variable. In this case, we're taking an integer. If the integer is 1, we're going to print out, you picked a small number. If the integer is 2, you picked a medium number. If the integer is 3, you picked a high number. And I also had a default case down here, but it's not showing up, which is too bad. So basically, this is just another syntax. We could have implemented this exact same thing with if and else if statements, but when there are lots of different conditions and lots of different variations on what you want to do for each input, this is an option. So it's just a good syntax to know. Yes?
Why is there not like the backslash n the first one?
Oh, for up there?
Yeah.
Okay, so there's no backslash n up there because the get int, so if you try this, it'll give you this prompt. Give me an integer between 1 and 3. And if I put the backslash n, it would take me to the next line, but I just wanted them to type the integer right after the colon. You could have put the backslash n. It's not a big deal. Yeah?
For this code, this is case 1. Is that because the first case, because
No. So this is give me an integer between 1 and 3. If n is 1, I print this. Now, if I had asked for letters, I could have said give me a letter between A and C. Then this would be case A. Yeah.
the case is just
Yeah.
is given.
Right. Yeah.
What do you want to have more of a relational expression? So instead of saying n equals 1, what do you want to say n is greater than 1 as your first case?
Well, so actually, if I do not define some of these cases, this would carry down. So actually, maybe this isn't what you're asking, and maybe
I think she's asking is like if the case was like n greater than 0, case n less than 0.
Maybe
But
the switch statement is not really what you'd want to use. In
The
that
switch
case.
statement is just for value. So you're like checking if the value is like this or that. So you cannot actually put conditions. Do you no? Okay. Yeah.
So what if the person types with like a 10?
So-
So that would have been my default case, which unfortunately you can't see.
Let
But
me
it
try to
says-
make them see.
Actually, you know what? Let's just go to study 50, and I will just like zoom in on the slides on study 50
Okay.
because this is just annoying.
Mm-hmm.
So let me actually go to conditions. It's just going to take a little while.
Can you take that off?
Oh, sorry. How do you take it out?
Restart.
Okay. All right. So I'm sorry. At least now we'll be able to see everything without it cutting off. All right. So if they put in a 10, we would default here to my default case. And I would just print invalid because I asked them to enter an integer between 1 and 3. Any other questions? Yeah.
So let's say for case 1 and case 3, the two, like let's say you wanted it to yield the same thing, so you
Yes.
picked a number that's not a medium number. So in that case, would it be redundant if you just like, would you just change the text for both of them? Or would there be like some redundancy? Is there any way to combine?
I think you can put like case 1 and 2 right next to each
So
other.
there are ways to combine them, but I believe you can only combine adjacent ones.
Yeah.
So if I did not define anything for case 2, this would apply to both case.
No, if you,
Oh,
if you
oh,
didn't
no. If
define
I
this
did
one.
not put anything for case 1, this would apply to both case 1 and 2,
Yeah.
if that makes sense.
Do you have a question? Okay. What?
Can you repeat that one for me?
Okay, if you did basically like, you have the same thing but you don't put anything here,
Right.
you'll be like, either for case 1 or case 2, do this. Right? And this break means like if you get into this case, just leave. So that's what the break means. So if I just did this, you like look, it's case 1, you go and you would just do this. If it was case 2, you would also just come here and do that.
But you couldn't do it if there's something for case 2.
You can't. I don't believe you can do that. I don't think
Do-
you can skip around. Like, can you do that, Rob?
No.
I don't think so.
No.
Yeah.
So only one number can go after a case, right?
Um,
It'd be like case 1, comma 2.
No.
I
No, you
don't
can't. You
think
definitely
so.
can't. Okay. Any other
I
que-
mean, the point is, this is an option, and this might not fit your use case, so then you would use the if conditions, or...
So why would you do this? The switch that you use?
So I would use this if there are, or if you have very defined... Actually,
values?
Lucas, you're blocking the...
Oh,
If you have very defined behaviors that you want for each and every input, this might be a little more concise than writing out an if statement for each one.
yeah.
So what does the break mean again?
So break means stop. So remember, if I didn't have this break here, we would have just fallen down into the next
So
case.
break means get out of this switch statement.
Yeah,
Because if it's 1, I want to print this and leave. I don't want to check anything else.
Want to check anything else?
right.
Yeah, it's just,
Right,
yeah, because
right.
it's mutually exclusive.
And does this only proceed to the next case if the first case isn't true, or does it test all the cases at the same time?
No, it checks sequentially. Sequentially, yeah. One more question, then we're going to move and then we get, so we can cover everything. Yeah?
So for the case, could you have done something besides just the one? Could you like give it a range?
No.
I don't think you can.
No,
give
you
it a
cannot. You cannot
range.
give it a range.
The case is like specific on
It's
Yeah.
specific. So switch is for values. You like doing different things depending on a value, specific value. You cannot do range. Cannot do anything else. It's just another tool. See.
Most people don't use switch statements very much
Yeah.
in CS50, but it's there. All right. So the next thing we're going to talk about is the ternary operator. And so this is just another type of conditional. And basically what's going on here is I'm asking for an integer. And if n is greater than 100, I'm going to print out high. If it's not, I'm going to print out low. So what it's doing is the condition is right here in the parentheses. You can kind of think of the question as I'm asking whether this is true or not. If it's true, I'm going to do this first thing. And if it's not true, I'm going to do this second thing. Any questions about the ternary operator?
Okay. Just one note from David is that whenever you have a condition,
I guess
like
David's
here,
watching via the
yeah,
live stream.
he's doing live stream right now. So whenever you have a condition, you're supposed to put curly braces. Do you guys, just like we have in a switch statement here, we have curly braces here. For whatever conditions, you're supposed to also put
Right.
that.
So you'll see this in the style guide.
style.
We don't actually have the style guide right now. I think
No,
David's still
he
working.
said that it's just
Oh,
working
is it
now.
working now?
Yeah.
Okay. So apparently this year in the style guide, even if you just have one line, you've got to put those curly braces in. So you don't necessarily need to for the functionality of the program. And maybe we should just take a break after the conditions and go straight to the style guide to clear up some of these things.
Yeah. Do you have a question?
No, just wait till the style guide.
Okay.
Okay. Ternary, yes.
Yeah. Yeah, so ternary operator is basically an if-else statement, but instead of having to have like the 2 lines of like checking an if and then the else, you just have 1 line. So basically, if I want to give a string a value of high or low, and I want to do high if n is greater than 100, or low if it's less, what I can do is basically say that the string is going to be, and then I ask the program, is n greater than 100? So that's why I have this expression in parentheses, and then a question mark. I'm like asking, is it greater than 100? If it is, it's going to be high. If it's not, it's going to be low. So basically what you think is you ask a question, so you put in parentheses the condition, then you put the question mark because you're asking it. And if this is true, it's going to be the first value that I put here. If it's not, I'm going to put the value that is after the column. Does it make sense? It's also like something that is like a tool in C, but you don't have to like specifically use it. But it's CS people usually like them because it just
It's
saves
very elegant.
lines.
It
Yeah.
does a lot in just one statement. So.
Yeah.
So the percent sign is just whatever the result from the previous line.
Oh, I'm sorry. So this percent sign is actually a placeholder for this S. So in a printf statement, you've got this string here, which is what's going to print out. But you can't just put this S in there, otherwise it would print out the S literally. So we put a percent here to keep this place held for whatever comes after the comma.
Yeah. Okay.
So for a string, you've got percent %s, for an integer percent %i, for a float percent %f.
We're going to
but
talk a little bit
You'll
more.
see those as we see
Yeah.
more examples. But maybe you should talk about the style guide for a little while.
Yeah, let's talk
Now
about
that
it.
it's up.
So if you go to cs50.net/style, you're going to see the style guide. So for problem sets, your score for the problem set is composed of scope, which basically means if you did all the parts of the problem set or if you attempted something. The second thing is correctness, which means is your program doing what it was supposed to be doing, or does it have bugs, or is it like not doing what it's supposed to do? The third thing is design, which means are you implementing this well, or are you being like using like unnecessary statements? So for example, if you want to repeat a number 10 times, are you writing a for loop, or are you just doing 10 times the same statement, just doing copy and paste? So design is for that. And finally, you have style. So style is just like judging if your code looks like readable and kind of like pretty. It just basically means, is your code readable? Would someone else who was looking at your code be able to understand what it's doing? Does it have comments and the like? So let's talk about the style they're supposed to use. Okay, the first thing is comments. So comments are very important for your code because sometimes you're doing your program and like you know exactly what you want to do, so you just start like coding and like just type up a bunch of C, but if someone else is looking at your code, they're not going to be able to understand it because they don't know the things that in your head, like the pseudocode, so maybe they'll have a hard time to understand what the code is doing. So comments are really useful to explain to someone who's looking at your code what it's doing. And actually, even for you, they are very useful. As you go to harder and harder P sets, like you're going to see that the code gets longer, and then comments are really important so you remember what each part of your program does. To put a comment, you can just do // and then write a comment, and that whole line is part of a comment, and whatever you write down, it's not going to be used for your code. It's just like, basically like the compiler is going to ignore that. Does that make sense? Yeah.
What do you do again to write a comment?
This, the //. Yeah. So whenever you type // like whatever is in that line is not going to be considered to be C. Yeah.
So and the comment would be just during starting line.
Yeah.
Yep.
Yeah, exactly.
So the // is for single line comments.
Yeah. So for example, here we have, let me zoom in. So for example, here I'm declaring a float, but maybe if you just put this in your code, like you have no idea what this is doing. Like actually, like someone who's looking at this code is going to be like, what the heck is going on? So if you put a comment saying convert Fahrenheit to Celsius, it makes much more sense. You're like, okay, you're doing a conversion. Does that make sense? So so it's just something that helps people read your code and also make you be able to organize your code better. The second thing is that you can do multi-line comments. So have one comment for a bunch of lines. So instead of having to put like // the first line comment, // the second line, and so on, you can use the /*. So the way that you do it is that for the first line of the comment, you're going to do /**. So just like that. Just like here we have the beginning of a program. You usually put who you are, like what this program does, and stuff like that. It's kind of like a header for the program. Again, it's not something that the compiler is going to care about, but it's important for you to like know what this program does, or for other people to know what your program is doing. So you do /**, and then the last line, you're going to do // to be able to close that comment. Okay, so you can so basically for all the other lines, you can just write out whatever, and this is all going to be ignored. Okay? And also, just as a style, you see that each of the lines has a star, and all the stars are aligned. So these are important things so that your code looks pretty. Sounds good? Okay, so now conditions. So what David was saying that we should put in those slides is that when you have any kind of if statements or any kind of conditions, you should use curly braces to show that this is what is going to happen when you have the condition. Technically, when you have a condition and then the next line is just one line, you don't technically have to put a curly brace, the curly braces. Basically, the compiler would understand it anyways as implicit. But for CS50, we ask you guys to put the curly braces just so that your code is more organized and more readable, okay? Because that code gets longer if you don't have curly braces and such, it gets really messy.
So this is exactly what David just pointed out. In my previous slides, it definitely works without the curly braces, but for stylistic reasons, we're going to ask that you do put those in.
Yeah.
And when you start running style 50, which is kind of the check 50 for style, it will remind you to do this.
Yeah.
So.
And another thing is that remember to put the curly braces alone in each line. So you do, for example, else, go to the next line, open the curly brace, then you go to the next line, indentation, which is 4 spaces, then you write whatever, then another line, and close the curly brace. So be sure that both these curly braces are in different lines. Yeah?
So if this code had 10 else ifs, there should be 10 sets of brackets.
Yeah, for each of them, yeah. So if, else if, and so on. Okay?
Can you not press tab to indent?
So we're asking you guys to use 4 spaces. Some text editors translate tab as 4 spaces automatically. Gedit doesn't, so you have to do space, 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 space. Okay? It's just, this is also something that some programmers only do tabs, some programmers only do 4 spaces, some other people even do 2 or 3 spaces. In CS50, we're asking you guys to do 4 spaces.
There's almost definitely got to be a way for Gedit to
You can,
automatically do tabs.
yeah.
Yeah.
Does that.
I mean, yeah. I think you can go to settings, but
It auto does.
it already does? Okay, so just be sure that you have 4 spaces. Yeah?
Do we have to put the curly brackets in for loops as well?
Yes.
Yes. Yes.
So whenever you're encapsulating a block of code, just please use the curly braces. And before you think that we're kind of just being sticklers about this for no good reason, if you guys do go on to get tech internships at big companies, they will give you a style guide, and they will tell you this is what your code needs to look like. And even though you learn to code like this, maybe in your internship you'll have to do something completely different. They do expect you to conform to their style.
And one more thing is that, do you notice how I have x space less space 0? Whenever you have an operator, it can be plus, minus, times, less, greater, whatever operator, you have to put a space between, on the left and the right of the operator. Okay?
So those are called binary operands. So just make sure you always space out your binary operands.
No, this is not a binary operand.
That is, because it takes 2 things. Yeah.
Okay. Okay. The switches. First, you have to see that just like in an if or else statement, you have to put the curly brace on its own line and another curly brace here. Notice that there is a single space after switch, just like in if and else, we had a single space between that and the parentheses, so you have to put that. and there's no space right after each of the parentheses or before the end of the parentheses. So you see that it's all together, and also like up here. Yeah?
I think we need to move on.
Yeah, okay.
Shall we just, so.
And okay, so this is like part of style guide that you have for CS50. Be sure to go to cs50.net/style and take a look at this. These are all very important for your style score. Okay.
So.
Let me go back to style 50.
I'd rather just use style 50.
Yeah,
I'm
so
just
loops.
going to go straight to loops.
Okay.
All right. So let's get back to the content now that we've gone over the style guide. Loops, you've seen them in Scratch, and we're going to talk about them in C. All right, so in a for loop, there are three portions to the declaration of this for loop. You've got your initialization, in which you set your variables. You've got your condition, which you're checking to see whether something is true or false, and whether the loop should continue. And you've got your update, which is updating your variables. So let's just take a quick look at some C code of this for loop in action. So what's going on is here in the initialization, we're setting I to 0. In the condition, we're checking whether I is less than 10. And in the update, we're incrementing I. So what will result from this for loop?
Actually, first of all, do you guys know what I++ is? Increase by 1.
Yep.
Yeah, so there's the same thing as doing I equals I plus 1. And notice that we don't have a space between the I and the plus plus. Yeah, any questions? Okay, so do you guys know what this would do? Can someone tell me? And maybe get some candy because of that? Okay, I'll give candy to everybody later. Yeah, it's going to show this is system 10 times.
Oh, I guess it was in the title of the slide.
Oh, yeah.
Okay.
Oh, that helps.
All right. So those are for loops. We're going to see some more examples of for loops later on. But let's actually take a look at the second type of loop you'll encounter in C, and it's called a while loop. So in a while loop, you've just got a condition. The condition is checked in the beginning. And if that condition evaluates to true, then the code within the body of the while block will execute. And the code will continue to execute so long as that condition remains true. So here's an example of a while loop in C. We're going to set count to 10 to begin with. As long as count is greater than 0, we're going to keep printing out this variable here. We're going to decrement count and then check the condition again. Print, decrement, check the condition again. So here we have an example that pertains to your question earlier. We had the %s when we were printing out a string, and now that we're printing out an int, we have a %i as our placeholder instead. So the letters should all be pretty intuitive. S for string, I for int. So all right, so if this code executes, you should count down from 10 to 0, printing out each integer.
Yeah, you can think of the % as if it was like a blank space, and then you're putting this variable here in that blank space. So for example, here, I'll have like just a blank, and then I'm putting the count right there, the value of the count. Does that make sense? If I had, could I just do like printf and then quotes count? Would that work? No, because it will actually print the word count instead of printing the value. So this is how you make it print the value stored in the variable instead of just the name of the variable. Any questions? Yeah.
Why do you use for as opposed to while?
So I would use a for loop if I know exactly how many iterations I want my loop to run. In this case, it doesn't matter because, I mean, I was just trying to think of a really simple example for this slide. But let's say that you want something to keep going while...
For example, you're asking for input until the person gives you the right input. So like while the input is not okay, keep asking for it. Or like while your parents don't give you money, keep asking for it.
You don't know
It's
how
like
many times you'll have to do it.
Because like you don't know how many times that's going to keep
But
going.
in a for loop, you need to know how many times.
Yeah.
Yeah.
Just clarify, the % says this is something's about to happen. The I is an integer, and the
means? Who knows what the backslash n means? New line, yeah.
You can
Exactly.
think of n as new line.
Nice.
Yeah.
What's that count dash dash?
Oh, so count minus minus is like the same thing as plus plus, but instead of increasing, it's decreasing by 1.
Yep.
Okay.
Any more while loop questions? No? Oh, wrong laptop. Oh, we were supposed to have skipped that. Okay. So this is a do while loop, very similar to a while loop, except in this case we check the condition after the code in the body of the loop executes once. So we execute the code first, no matter what. Then we can check the condition, execute it again if the condition is true. So you'll find yourself using this when you're asking for user input, because you're always going to have to ask once, and then depending on what the user input is, you might have to reprompt and ask again and again if the input was not what you expected it to be. Yeah.
This is like on forums when people don't fill out
Yeah, exactly. Right. So you'll find, I think in your very first P set, you're going to have to use a do while loop to collect input from the user. Yeah.
So depending on the situation, do while loops will tend to run more often than while loops, like by 1 or something.
I mean,
If it's the exact.
they should always like run the exact amount of times that you want it to run. I mean, like we use do while because we really want to get the input at least once. In while loops, sometimes you don't want to execute it at all if it's not the case to execute. So it depends on the design. I mean, you can either use do while or while as long as your code does what it's supposed to do.
But I do think the answer to your question is probably yes. Let's say the condition was false. In one case, it would run once. In the other case, it would run 0 times.
Yeah.
So, yeah.
Yeah.
Any more questions? Yes.
Can the loop condition in a for loop be in terms of variable other than I?
Yeah, it can
Yeah.
be
It
anything.
can be anything.
Probably for the beginning P sets, you won't have to encounter that case, but
But you will
definitely
see later.
can be anything.
Yeah. I think we're done here.
Are we? No?
Loops? Yeah.
We should not be. Oh, we are done with loops.
Yeah.
Okay. All right. So actually, because we've been talking so much, let's actually all navigate over to study.cs50.net/conditions. And you're going to navigate down to the problems widget. Well, actually, while people are getting this set up, the CS50 study is going to be a tool that your TFs will use to prepare for sections and that you guys can use if you miss sections. It's going to contain a bunch of slides, some tips and tricks for each topic, and some practice problems with solutions. So why doesn't everyone just take a look at this problem right here? I'm sorry, I should have reminded people to bring laptops today, but if you don't have a laptop, that's okay, and you can just jot this down on a piece of paper or look over your neighbor's shoulder. So let's try and write a program that prompts the user to take a guess at the average number of children per family in the United States. That number is 2, by the way, as you can see from these examples. So we want to print out average number of children per family in the US. Then we want to what? What do we want to? We want to collect input from the user.
That's actually like talking
And then,
pseudocode.
depending on what the user's input is, you're going to print out either this is correct or this is incorrect. And the very first thing that you'll see if you click the little arrow at the bottom of the problem widget is a spot to jot down some pseudocode. So you're not programming yet. You're just like getting your ideas in order. So does anyone want to help Lucas come up with the right pseudocode for this problem?
What is the first thing that we should probably do here? Where you guys? Yeah. Yeah,
Yep.
well, yeah, okay. So print, wait, just say the print, that's average number of people. Yeah, okay. Print question, let's say.
Yeah.
Okay, after I print this question, what should I do? Get input.
Nice.
Anything else? Sorry?
Yeah.
Condition? Anything
So
else?
what is that condition going to be? Right.
So what am I going to check in the condition?
If it equals 2.
Yeah.
Exactly.
Okay.
Mm-hmm.
Is there anything else that I should do?
Uh-huh.
So if it's equals to 2, let's say, let me just write, if input equals to 2, then what I'm going to do is print correct,
Mm-hmm.
and then else I'm going to print incorrect. Okay.
Nice.
Anything else? No?
All right,
Okay.
so you can click on the... Oh, does everyone have this down?
Yeah? Does it make sense? Okay, so now let's try to code this.
If you click the little arrow, it actually saves your pseudocode, which is really exciting. And you can make those into comments if you want,
Yeah.
just to remind yourself of what to do.
So for example, first I'm going to print the question. So how am I going to do that actually? Printf.
Yep.
So printf, and the question is average number of children per family in US. Okay. Then I'm going to get input from the user. So how can I do that?
Mm-hmm. Get in.
Okay, so first declare, right, int, let's call it n equals getInt. Okay,
Nice.
and now the condition. So let me say that I'm gonna here check answer. So first, if input, which is n, equals 2, how am I gonna write that?
Nice.
Perfect. So and notice that I do a space equals space 2. And now what should I do? Something very important for style, the curly braces. And then I'm going to print. How do I print? Printf. So
If be capitalized?
what?
Could the if be capitalized?
No,
No.
it's supposed to be all lowercase. So that is correct. Oops. Would this suffice for the printf statement, or am I missing anything? New line,
Yep.
yeah. And now else.
Is there a space after printf or no?
We should check this.
We should check the
Style.
style guide. Shouldn't be, okay. So else printf, that is incorrect. Okay,
Oops, your code.
oops. Okay, anything else? Does it look good?
Shall we try it?
Yeah, let's run it. So it's compiling, and it seems that it works. Let's try. Let's try 2 children. That is correct.
Nice.
And now let's run again, but now instead of putting 2 children, let's say that I'm gonna put like 5. That is incorrect. So it seems
Why
that it
don't you
works.
show them what happens if you put like something weird, like some letters?
Oh yeah, let's also like check that. What if the user is trying to mess up your program and they just write, I don't know, 2. It's basically going to say retry.
So getInt is asking them to retry. We didn't have
Yeah.
to take care of that ourselves.
Yeah, so unless I actually put a number, it's going to keep asking me to retry.
How did you run it?
Just click the
Actually,
start button.
you should go up. There you go.
The start button right there.
Yeah,
Yeah?
I believe it will.
If it does what?
If they type in a decimal number, I think it's gonna prompt
Let's see.
because it's not an int.
Yeah.
So if it's not an int, getInt will ask you to retry.
Yeah.
Yeah.
So where in that code would be the best place to prompt the user that they have to enter an integer
So getInt is actually doing that for us.
No, I mean, if we wanted to use it.
You can say like average number of children in the U.S. I don't know. Okay, we can say, for example, please
Enter
input an integer.
an integer equal to the average number. I mean, it's just how you word it, right?
Yeah, this is like not part of actually coding. It's more of like the whatever you're gonna want to write in your program. Yeah.
Yeah.
So how would we have run it if it was actually the gedit window instead of like pressing play here?
We will first compile it. We can do by doing make and the name of the file. And then to run it, we'll do // and the name of the program. Okay?
I guess what I meant was like, if we wanted the program to respond to their invalid entry,
We would,
that you should have put in.
yeah.
Would that be like,
We will not be able to do that because the code that says retry comes from getInt, which is a function that is already implemented for us by the CSFT library. And since it's already implemented there, we cannot
Right.
like just
I mean,
decide to.
If you figure out, if you don't use getInt, then you can do that.
Yeah, yeah. But if you're using getInt, you can't. Okay. Any other questions? Yeah.
So could you have gone with like get float and have then be able to like or be able to put it as decimal?
Yeah.
Yep.
Okay, then you just continue like and put like float n equals.
Yep. Exactly the same, except
Exactly.
a float instead of an int.
Yeah. Just put it here and then get floats there.
As we will see or have seen,
We have not gotten there yet.
doing inequality with floats doesn't work.
Yeah. Yeah.
Yes.
What do the semicolons mean?
So the semicolon just means that this statement is complete, and we're
Yeah.
going to go on to the next line.
Yeah.
So it's necessary every time.
Yeah.
Yeah.
Okay. So not for these conditions, because they're encapsulating something. So basically, if something is causing you to then create a curly brace block, don't put a semicolon at
But
the end of that
everything
line.
else, yes. When you finish a statement, put the semicolon. And if you forget semicolons, the compiler is going to get angry at you, and you're going
Right.
to have to try to like fix it.
Now let's think about if I put a semicolon here, that would stop this, and I would never get to execute what's inside. By the way, so it's one of the most common bugs. Or always, actually, yeah. In this case, we would always execute what's inside.
Yeah.
This year's style 50 would catch that for you, though.
Oh, that's true.
Because it would be a single line thing without parentheses.
True.
Yes.
Can you have multiple inputs in one line? So like, can you ask the user to put in two things?
Not using.
No,
get-
you have to like do. Let's say that I also want to get this integer m. I have to do in a different line.
So like, if you were to run that, like, how would that look? So it would print the prompt there, please put input integer, and then you would enter one, and then
Well, run it. I mean, there's nothing stopping us from just running it and seeing what would
Yeah.
happen.
I think it's gonna complain at us because we're not using. Yeah.
Oops.
It complains
You
at
just
us
need-
right now because we're not using this variable. But if I did, for example, n is equals to and m equals 2, then you would then what will happen in this case? What would this program do?
I was just wondering how it would.
She just wants to know how it looks, I
Yeah.
think, right?
Yeah, it's gonna.
Right. So it took
Get
one
you
of them,
numbers.
and then it took the second one.
Yeah.
So, I mean, all right. I think we should move on because we have one more slideshow to go
Yeah.
before. Do you want to pull up math?
Yeah, math. Okay.
Give me just 1 second. All right. Okay, so there are a few different numerical variables in C, and so numerical data in C can be classified into different types, and these are the ones you'll see the most often. So an int is a whole number; you can't have any decimals. In the appliance, it takes 32 bits to store an int. A float can have decimals. It also takes 32 bits to store a float in the appliance. A double is a number with a decimal point that takes 64 bits to store it, which means that you can just have greater precision because you can have more, what do you call it?
Yeah, that's
more places after the decimal point. And a long is a whole number that takes 64 bits to store
it can be
in the appliance.
larger than ints can be. Yeah.
So the thing about data types in C is that they tell you what kind of data you can store in your variable. They tell you how you can use this variable in your program. It's very important to just keep track of what data type you're using, and if you do need to cast from a data type to another, make sure that you know exactly what happens when that casting takes place. And you'll see an example later on in these slides of a mistake that can occur. So let's just take a look at some math in C and think really carefully, I guess, about what's going on when this math is taking place. So in the very first line, what's happening when I declare x?
You're allowing x to be something.
Yeah, well, so I'm really asking the operating system for 32 bits of memory, right, in which I can store an int, and I'm going to call that int x, right?
Basically going in memory and finding a place that has 32 bits and saying, hey, I want this place, and this is going to be called x. So you're just pretty much finding a box in your memory to store values for x.
Okay, and then I initialize x, which means that I just store the value of 2 in that place that we asked, that chunk of memory that we asked the operating system for. And down here, what we're doing is we're actually declaring and initializing y in one line instead of in 2 lines like we did up here, which is also perfectly fine. We're adding 1 to x, and we're storing that value in y.
So basically what this line does, it finds now a box for y, and then its value, the thing that you're going to put inside the box, is going to be the value of x plus 1. So it has this box for y. It gets the value of x, looks here, and sees that it's 2. Put it there, plus 1. So you put 3 there. Does that make sense? So y will be 3 in this case.
All right. All right, cool. So we saw some addition. So let's now think about division in C. So here I'm declaring and initializing a float called answer. I'm dividing 1 by 10, and then I'm printing out the answer to 2 decimal places. And note here in my printf statement, when I want to print something to 2 decimal places, %.2f is what I want to use. And the point is saying, so the 0.2 is just saying I need 2 places after the decimal printed out. Now, what's going to happen if I run this code? Does anyone have an idea? What would print out?
What are we expecting to get?
Yeah, what do we
first
want, first of all?
What are we waiting?
0.1, yeah. But what will print out? Well, no, actually. So this is what I was talking about, why you need to keep very careful track of your data types. So what data type is this? This is an int, right? There's no decimal place. 10 is also an int. There's no decimal place. If I divide an int by an int, I get an int, which is not 0.1, because ints can't have decimal places, but just 0. Because an int just truncates off the decimal places.
So whenever you do operations with ints, you're going to get an int as the answer. So basically, like what the computer's doing, it's like it divides 1 by 10 and it gets 0.1. But then it's like, wait, this is supposed to be an integer. So you just ignore the 0.1, so it's now just 0.
So when I print this out, I get 0.00 rather than 0.10.
Does that make sense?
So that's kind of unfortunate, right?
So how can we fix this?
So let's try and fix that. All right, so here's an example of where I'm actually casting the 1 and the 10 to floats. So now 1 is no longer an int, 1 is a float. So this, by the way, this is just the syntax for when you want to cast from one data type to another. You can just put the data type in parentheses and have that just precede the data type, the value that you're casting. So here I'm dividing a float by a float to get a float answer. And yes, this would in fact print 0.10.
Yeah.
Does that make sense?
So typecasting is just converting from one type to the other. So instead, float 1 is actually 1.000. It's like not exactly this, but it's something like with decimal places that is actually 1. Does that make sense? Yeah?
Or if you did float answer equals 1.0 divided
Then
So you're actually going to see that in the next
Yeah.
slide.
that's so
That's
another way.
actually our very next slide.
Yeah.
Another way. This is actually nicer than typecasting, I think. So these two are floats just by nature of the fact that they have decimal places.
Yeah.
Yes.
So, but I mean, what if we did 1.0 divided by 10?
That would actually a float divided by an int actually gives you a float. So that would work fine. Yeah.
Good.
So wait, does everyone understand this? Because this is going to be a really big deal in PSET 1, actually. Yes. The red part, yeah. Lucas,
Okay.
do you want to?
Okay, so remember that the percent is a placeholder. It's like a blank space. So let's try to like understand everything that is going on here. So percent means that it's a placeholder. Then you have the f, which means that this placeholder is for a float. The last thing that we have here is a .2, which means I want to have 2 decimal places for the float. If I just had %f, then it will put a bunch of decimal places. So I can just put like .2 or .1 or .5 or whatever, and it's going to put that number of decimal places. The only thing is that if we put like .100 or .1000, it's not actually going to put like all those decimal places because it doesn't have enough memory to have that precision. Any other questions? Yeah.
So float just allows you to go beyond integers? Is that
Yes.
Well, a float just allows you to have decimal places.
Yes.
Okay.
It just
Does that
means
make
that you
sense?
now can have decimal numbers. Yeah.
Why would we ever use integers?
What?
Why would we ever use integers?
Why would you use integers? So maybe if you're counting from like 0 to 10, you want to like use exactly an integer. You don't need to use a float. In some situations, you don't have to actually like.
Maybe you don't want decimals.
Maybe you don't want to use a float.
The other thing is when you start using, so remember both a float and an int take 32 bits to store them, and maybe you don't want to waste bits on the decimal places.
Yeah. Yeah, just for the fact that, so like, just think about this. You have 32 bits for both an int and a float. For an int, all those 32 bits go to the integer part. If you use a float with 32 bits, you have part of this memory being used for the number, for like the whole number, and the other part being used for the decimal places. So that means that you cannot get to like very large numbers with floats because the float's already using a lot of memory for the decimal places. Yeah?
That first answer, what exactly is it doing? Is it setting the value of float equal to that placeholder so that you can recall it in the next line? It says float answer.
Yeah, so float answer means, okay, you getting out a little bucket in the memory to put that like holds a float, and that's going to be called answer. So that's what float answer does. And then you say that inside of this, you're going to put the result of this. So you're going to do 1.0 divided by 10.0, you get 0.1, and then you put that inside of answer.
So in one line, we're declaring and initializing this float called answer.
Yeah. So interestingly, although this is just like one line, it's doing multiple operations. It's just a way of C letting you use less code. It's the same thing as like the ternary operator, how you can just do an if-else in one line. It's actually doing the same thing as like doing float answer, semicolon, and then answer equals this. But instead of making you do 2 lines for that, it's kind of like a shortcut. Yeah.
So if you ran this, it would be 0.10.
Mm-hmm.
Yes.
Yep.
You know, yeah.
Is answer actually code or is it just the name?
So this is actually code. This is what we're going to name our variable, right?
Yeah.
So it's just a name though.
Yeah.
It's
So
a
I could have
name.
said float x equals 1.0 over.
Yeah.
Yeah.
So the thing is that the name of the variable is something that you use. It's important for you. For the actual program, the only thing that matters is the value that you have inside of that bucket. So the reason why you have variables and names of variables is so you know what you're dealing with, like what kind of data you're accessing at a time. But for the code itself, if you call it answer or question or anything pretty much, it doesn't matter. It doesn't matter. As long as you're consistent in like every occurrence of answer, you call it something else. Yeah?
Yeah. Do the variables go beyond the function? Like if you were to create a bracket or an employment function, if you use the variable answer again,
No.
deeply, yeah.
No.
No.
So that would be outside of the scope of this particular variable. And actually, that's kind of interesting because when we have things like loops or these if conditions, if you declare a variable within another set of curly braces, it really only exists within those curly braces.
Okay.
Is floats,
Yeah.
it's like an order of magnitude faster. So if we just handled only floats, things would be a lot slower.
Yeah.
Actually, you'll
And
soon
the
see a
reason-
problem
yeah.
with floats.
The kind of the reason for that you can think is how like in binary you can represent integers by putting
That's the
zeros
next
and ones.
thing.
Yeah. Okay. Awesome.
Wait, just hold that
Okay.
thought.
I'll explain that later.
All right, so before we get to what Lucas was just saying, operator precedence, this is common sense. You guys have done this in math. So, just if something's in parentheses, it will happen first. If multiplication takes precedence over addition, subtraction, things like that. So actually does anyone want to tell me what number 1 actually evaluates to?
Yeah.
27? Yeah?
Okay. Let me give 10 to people.
All right, what about number 2?
Sorry.
What about number 2? 22, yeah. I don't know who got that. Number 3. 10, yes. All right,
Okay.
cool. So modulo. Lucas, do you want to explain modulo?
Okay, so modulo is this operator that is actually very useful for a bunch of problems. That basically does, if I do 55 modulo 10, what it does is, let's say that I want to divide 55 by 10, what do I get? If it was just like, if I'm actually just doing the division, what is the first number that I get, the integer? 5. And then the remainder is 5, right? So it's like 5 times 10 plus 5. Basically what modulo does, it tries to divide this number by this one, and it sees what is the remainder of the division.
Yep. So it just returns the remainder.
Yeah.
So number 1 is what? 5. Number 2? 3.
Yeah.
Number 3, 0.
Yeah.
And 4 is 1. Exactly.
Yeah, simple, right?
All right. All right, so why don't we skip this just because we don't really have time and people seem to understand.
Okay. So,
All right, so here's what Lucas was just talking about.
So another reason why I would use ints instead of floats is that floats are very imprecise. And why are they imprecise? So like David said that to represent an integer, for example, we use zeros and ones, right? And then you basically do the multiplication, do all those operations to know what decimal number you have instead of the binary. What happens now if I try to put decimal points? Actually, for example, if I have the number 3.33333, it feels like 10 over 3. How am I going to store all the 3's that I have after that? It's really hard, right? The computer you cannot just tell the computer, hey, I have a 3, and then you do that forever. Actually, the computer is not smart enough for this. So basically what your computer does is that it tries to put as many digits as it can up to the memory that you have. So let's say that it's going to say 3.33333, and that's it. So it's not able to actually express precisely what that float is.
So we have a finite number of bits, which means that not every decimal number is going to be able to be represented precisely.
Yeah.
And so in this example, if we're printing out 0.1 to, we're now printing out 20 places, right?
Yeah, just like I was telling you guys, you could put any number, but if you just did the 2 places, you get 0.10. But if you put 20 places,
Look
it's
what
going
we
to
get.
show you a bunch of zeros, because this is what you can put in the memory, right? But right here up to the 0, and then it's just putting a bunch of random numbers. This is kind of some
So this is just because we're not able
a
to
trash
represent this decimal precisely with the number of bits we have.
And then the computer is basically giving you a trash number. This is not actually the value of the number.
I don't think it's as clear. Yeah.
Yeah. Exactly.
So the implication of this is that let's say that instead of being 0.1000014 or whatever, what if it was 0.0999? Well, okay, I guess this is. Let's pretend that the actual answer to this was 0.9999999. Right? So that's very close to 1, but it's not exactly 1. It's 0.9999999. That means that if I take that 0.999 and I cast it to an int, I get 0. I don't get 1.
Because remember, casting from float to int, you just like ignore all the decimal places. You like just ignore them. There's no such thing as rounding up or rounding down when you typecast. Actually, there's this function that does rounding, which is very important, but you can just think that when you do typecasting, it's just going to delete everything. So even if you have like 0.99999, it's going to just give 0 if you typecast it to an integer.
So just be really aware of floating point and precision, especially when you start to use floats in pset 1.
Yeah.
But the walkthrough should warn you of that as well.
And actually, like, it's really hard. For example, if I did float answer 1 equals 1.0 over 10, and then float answer 2 equals like 10.0 over 100.0, maybe if I did, they're the same number, right? 0.1, right? 1 over 10 or 10 over 100, right? But now if I try to like see the equality, like if answer 1 is equals to answer 2, maybe it's not actually going to be the same thing. So like floats are kind of like bad at like doing equality.